All right, last video. I think at least for today. We're gonna find the zeros of these functions now. So we've done this before, kind of. We did this back when we did normal quadratics, but now we're doing it again. But we're doing it with quadratics that have complex solutions, quadratics with imaginary solutions. So last time they would have worked nicely. They would have worked out as real numbers, but now they don't. So we're going to do those. It's a pretty similar process to one you've known how to do, you've done in the past. That's the quadratic formula. Okay, it's still the quadratic formula, but we have to make sure that we can simplify in terms of I. That's the key here. So let's go ahead and get going. Now the quadratic formula, don't forget, is, where should I write this? Negative b plus minus the square root of b squared minus 4ac over 2 times a. So here our quadratic is already set up for us. A is our x squared value, but it's 1x squared, so a is 1. B is negative 5, and c is 10, right? Because it's got ax squared plus bx plus c. I'm going to clean this up just a little bit. Well, it looks exactly the same, but we're going to go with it. So I'm going to plug in the a, b, and the c, and we're going to simplify from there. So negative b. This is tricky because b is already negative. B is negative 5. So a negative 5 makes that now a positive 5. So I'm going to write positive 5 there. B squared. So I have negative 5 squared minus 4 times a. A is 1 times c. C is 10. Extend that a little further. All right, and this is all divided by 2 times a, which a again is 1. So I've plugged in all my numbers, right? Plugged in b, plugged in a, plugged in c. Now I'm going to simplify. So it's going to take a little bit of a process, but let's start with the inside the radical part. So the negative 5 squared, negative 5 times negative 5 is positive 25. So I'm going to put positive 25 there. Hold on a second. Let's go ahead and finish writing this. I'm not changing the 5 plus or minus yet. I'm just worried about the inside of the radical. So this becomes 25. Now minus 4 times 1 times 10. So negative 4 times 1 times 10 is negative 40. So I'm going to have 25 minus 40 there. And all divided by 2 times 1. 2 times 1 is 2. Now I can also subtract 25 minus 40. That's something I'm capable of. 25 minus 40 is negative 15. So I'm going to have the 5 plus minus square root negative 15. All divided by 2. Now here's the issue, because before, when we did these problems, we didn't really have to worry about a negative square root, but now we have negative square roots, which means we have complex solutions. So remember a couple videos ago we talked about how to simplify square root of negative numbers. So let's take the negative 15 off to the side for a moment. Okay, let's teach it a lesson. Right. Just kidding. We separate the negative from the number itself. So separate the negative, call it negative 1 from the, really, I'm going to teach this thing a lesson, from the 15, right? Square root of negative 1, we always call the same thing. Square root of negative 1 is I. We call this I. Now, square root of 15, 15 is not a perfect square. Remember, the perfect squares are 4, 9, 16, 25, etc. 15 is not one of them. 15 is not divisible by 4, 9, 16, or 25, or any of those. So we can't simplify the square root of 15. So all I really did was take the negative out and called it I. But the square root of 15 stayed there. So, but the negative becomes I. Because it's fancy that way. Why? Because it's fancy that way. That's why. All right, so that simplifies simply into I squared of 15. So I have still, okay. So I still have 5, still have plus and minus. But now, instead of writing the square root of negative 15, I'm going to write I squared of 15. Right? Because that's just simplified into I squared of 15. All divided by 2. And that's going to be it for this problem, because there's nothing else I can simplify. If there are any numbers that I could reduce by, the 5 or 2 or something like that, then I would reduce them. But I can't reduce the 3 parts to this. So that's as simplified as I'm going to be able to write my answer. If you type it in the calculator, if you solve this in the calculator, it's going to give you some crazy decimal numbers equivalent to this. But we're going to leave it like this for now. Because cool stuff, right? All right. So anyway, it's just a quadratic formula. simplify pieces of the quadratic formula. The key is once you get to the square root of the negative part, make sure you can simplify that. Okay, that's very important. That's the biggest thing to this problem. Let's try another problem. Expose ourselves a little bit more to this. So here, I can't start the problem yet until I have the ax squared plus bx plus c equal to 0. So I need my quadratic b equal to 0. So to do that, I'm going to subtract 15 on both sides just to move the 15, get that side to be 0. The 6 minus 15 is negative 9. So this is going to be negative 2x squared plus 4x minus 9 equal to 0. So that helps now because now I know what a, b, and c are. A is negative 2. B is 4. And C, most importantly, is negative 9. So make sure we did that correctly. And now we can actually use our quadratic formula with those. So negative b is going to become negative 4 plus minus b squared. So it's going to be 4 squared minus 4 times a. A is negative 2 times c, which is negative 9. All divided by 2 times a. And that's going to be 2 times negative 2. So there I go. I just plugged in everything. Now I'm going to evaluate. So leave the negative 4 plus and minus alone. I really focus my attention mostly on the radical part. 4 squared is 16. So I'm going to change that to 16. Now I got to be careful with all these negatives. Negative 4 times negative 2 times negative 9. That should give me, I believe, let's see, 8, 9. I believe that's going to be minus or negative 72. So minus 72, all divided by negative 4. So 2 times negative 2 on the bottom gets me negative 4. Now I'm going to subtract 16 minus 72. So 16 minus 72 is a number. Can anybody guess what that number is? I'm stalling because I'm typing in the calculator and trying to find out. Negative 56. Just trying to save some time. Oh, punish me, why don't you? All right, back. No, this way. There we go. Negative 56, all divided by negative 4. So the catch is, just like the last problem, is how do I simplify the square root of negative 56? Well, again, let me do that off to the side here. So first thing I'm going to do is separate the negative from the 56. I'm going to call this I. Okay, square root of negative 1 is always just I. 56 is not a perfect square. It's not in my long list of perfect squares, but it is divisible by 1. It's divisible by 4? Is 4 the biggest one? Yes, it is. All right, so we're going to break 56 up into 4 times 14. Square root of 4 is going to be 2. And the I is still going to be there. So in the front, we'll have 2i, and the square root of 14 won't simplify. So negative 56, square root of negative 56 simplifies to this. So I'm going to use that to replace the square root of negative 56. So still have negative 4. Stop doing that. Plus minus. I'm going to write 2i, square root of 14. That's replacing my square root of negative 56. All divided by negative 4. Make that one a little nicer. There we go. Okay, too much. Sometimes, man. All right. And there's our answer pretty much. Now, the only thing that we have to worry about now is simplifying the answer. So the you don't have to worry about the radical part, but 3 numbers outside the radical. Negative 4, 2, and negative 4. If all 3 of them can be reduced, then you're going to reduce all 3 of them. So negative 4, 2, and negative 4 can all be divided by a negative 2. So when you divide them all by a negative 2, what do we get? Negative 4, this one, divided by a negative 2 would become a positive 2. Negative 2 divided by negative 2 would become just a 1, so it'll just be 1i. Square root of 14 is unaffected, okay, because it's inside the radical, so it's immune to this, basically. And then the negative 4 on the bottom divided by negative 2 is going to be a positive 2. So this is just a little bit cleaner of an answer. So don't let the simplifying at the end be the part that bothers you the most. It's one of those things that come with the territory once you just get used to the problem. The big thing, though, is plugging it in, but most importantly, simplifying. Why, though? Simplifying the square root. That's going to be key to this. Okay. If you can't simplify the square root, spend some time practicing that. Ask for some help. Come to tutoring, whatever you got to do. But you need to be able to do that. It's very important. All right. I believe we already did problems like this, but I'll do it again just to remind you. Actually, I think we did this exact one. I don't remember. But notice this is not a quadratic in the ax plus bx, ax squared plus bx plus c equals 0 form because there is no x term. It's just a squared term. So when there's just a squared term, you can solve this pretty much like a normal problem. So subtract 75, get 3x squared. I'm pretty sure we did this exact one already. Yeah. Divide by 3. Doesn't hurt to do it again, I suppose. X squared equals negative 25. And then you would square root. Now remember, because it's an equation when we're solving this, we have a positive and negative version of my square root. And square root of negative 25 is 5i. If you're wondering why it's 5i, I was hoping you could do it in your head. But if you forgot, this is the reason. Square root of negative 25, you separate the negative from the 25. Right? Call this I, and we call that 5. So together they make 5i. All right. That one works the same way, basically. If you want to do it, this one probably is a little bit of a typo. I think I need to fix that. But that's it for this. I'm going to leave you at that. I hope you found everything we did helpful. That was a lot of work on my part, but it's a lot of work on your part as well. So I make these videos for you. Heart emoji. Bye.